So this video introduces the idea of the mean value. You're obviously familiar with working out the mean value of a set of numbers and the principle of adding them all up and dividing by how many there are applies to functions as well. So in terms of the working that we're going to do for questions, we're going to be using this formula here. Which you will need to learn and understand where it has come from. Let's explain where the formula has come from. So I have a function. It's given here as an example with the curve. And what I'm doing is I am finding the area under the curve between two values, and then I am averaging that area over the given interval. So I'm effectively taking the red area here that is included when I integrate, and the red area here that isn't included, netting those two off so that I get a rectangle to describe the area. And the area of that rectangle is equivalent to the area under the curve between A and B. And so the mean value of the function is actually the height. So we've got it here identified as F with a bar on the top. So let's have a think about what's going on. The area of the rectangle is obviously F with the bar on top times by B minus A, the difference between the two limits. If we rearrange this, we divide through by the B minus A, I get that my mean value, the F bar, is 1 over the B minus A times the area. And we know that the area is found by integrating the function between the appropriate limits. And the integral of the function is the same as summing the areas between particular values. So that's where the formula that we're going to be using comes from. Okay, so let's have a look at the first example, which I've worked through here. So applying my formula, the mean value is 1 over the 6 minus the 3, applying using the formula, and we're integrating between 6 and 3 the function that we have been given. Okay, simplifying and integrating, we get this expression, subbing in and simplifying, we come down to the 457 over 2. So that's where the formula comes from and what we mean by a mean value. And that's a simple example showing you it being used. Okay, other things that you are likely to be doing with it are transforming functions. So if we have a look at the notes at the top of the page, you will see that if we're transforming a function, it affects the mean value. So if we're adding on a particular value, so we're moving the function up by k, that means that the height of the average area will move up by k. So our mean value is adjusted by adding on k. Likewise, if we multiply by k, we're stretching in the y direction, so the mean value is increased. And also, if we are reflecting in the x-axis, then the mean value becomes the negative of its original function. Notice it doesn't work for transformations in the x direction. So it's just something to bear in mind. Okay, let's move on to question 2. I'm not going to do question 2 in its entirety, and I'll just show you why. It's quite a difficult integration, or at least it's one that you need to think about. There are a couple of options. So what I will do in class is I will get you to work in pairs, discuss what your options are and work through the integration. However, the method for finding the mean value is identical to that we've just done in question 1. You are applying the formula and undertaking an appropriate integration. Okay. What I do want to do, though, is just discuss with you B and C, so that we can just look at transformations. So for part B, we're taking our answer from part A, so the result that we've got there, and then we're going to find the mean value over the same interval for the function when we add on 4, and then we're going to do the same when we apply a minus sign to it. So my mean value when I add on the 4 is going to be the mean value for the function when we have just x subbed in with the 4 added on. Notice I've used a slightly different notation here that you may come across. It's identified as S average. Sometimes you also see Y bar. So what's happening is we take our result from A, which is 4 log 9/7 divided by log 3, and we add on 4. In a similar way, we're reflecting in the x-axis, so my mean value becomes the negative of the result from A, 9/7 divided by log 3. So that explains what we do when we transform. So now I'd like you to go back and consider the integration.